Welcome to Opening Voices. I'm Quentin, CEO of Clever Cloud. Today, we are meeting Craig Prunty, the VP of SiPearl, the European company specialized in processor design. In this episode, we are talking about how to address processor market from a European perspective, for now and for the near future.
Hi everyone, it's Opening Voices and I'm Quentin and I'm still traveling to Europe to explain what are the good engineers and what are the good technology we are building there. Today I'm still inside the SiPearl headquarters in Maison Lafitte near Paris, and I'm no more with Philip, but I am with Craig Prunty. Are you doing well?
Yes. Perfect.
And what is your role at SiPearl? And we will continue discussing what we have done the last week and the week before. And we will continue a little bit with Philip a little bit later. So
Sure.
Explain me what is your role in SiPearl?
I'm responsible for product marketing. So we look at what products the market needs, what are our market verticals, how do we address them, and then how do we build the product roadmap.
Okay.
And then when we build the products themselves, do they function as expected, and how do we go to market with them?
No, we discussed that SiPearl had the goal to create a CPU, and the real one is like in a few weeks will be in production, and we will starting to play with at Clever Cloud in a few months now. What is the market that SiPearl address today?
So if we look at processors, and I've worked in processors for probably the last 20 years. So you have different markets that you address. There's consumer, things like tablets, PCs, phones. There's embedded. This is things like base stations or switches where you have a specific processor that's doing functions in these boxes. We build server processors. So they're very large processors, a lot of cores. They sit inside the servers, which are basically the backbone of the internet. So we focus on high performance computing. We focus on what we call data center. This can be cloud data centers, this can be infrastructure. And we're looking also at the enterprise markets, which is typically banks or insurance companies or people who have their own private data centers on premises.
And what is the kind of, why an ARM processor like the one SiPearl does can be interested from this kind of deployment?
So if we look at server processors, if I get it, looking at the different markets I talked about for embedded markets, typically this is software that the customer owns. If I look at Cisco switches, they have their own software stack. It's in-house. They might use some merchant stack, some Linux stack or something in very specific kernels, but in general, it's their software stack. They own it. For server, the stack is owned by nobody in particular. It's a lot of open. It's some specific ISV, so it's a very broad stack that's worldwide. So you have to have an ISA with all that code that's already ported to the ISA, the instruction set architecture. And if we look at the instruction set architectures today for servers, there are 3 that are ported enough to be useful to customers. x86, and that's AMD, and that's Intel. PowerPC or Open Power, that's IBM today. The third choice is ARM. And again, it's about the software running on the hardware. ARM is open to anybody who wants to license it, to pay for the licensing. So it's the most democratic solution.
So we already explained with it that there was lots of users of ARM, like Apple, like Samsung, like MediaTek, and many other stuff. Yeah. And those there is people making ARM in the server right now, or not at all?
There are many. So and there's a long history. Calxeda was the first company to start doing this. They were born. They started in 2008. They ended in 2012. There are many companies that started with ARM servers over time, and they were building this software ecosystem. Today, if we look at who's building servers on ARM, most of the hyperscalers.
So Amazon,
AWS, Microsoft.
Yes, with it's called the Cobalt stack.
Cobalt, exactly. Google with Axion.
Okay.
Then we have other folks that have been in this market and maybe back again, like Qualcomm. They bought a company called Nuvia that was doing a bunch of guys that were from Apple previously. Apple has a processor, but it's not really a server processor, at least as far as we know. They're not very open. We know that they're making the M1, M2, M3, which is in their
So consumer stack.
Exactly.
So basically, if you look at this, I'm very happy because we bring the Apple subject, because people think that creating the processor was a problem for them. If you look at the processor in Apple is not only the processor; they basically built everything inside it.
Software is so important for the hardware; it drives a lot.
Yeah, but if you look at the chip, inside the chip you have the NPU, the memory. That they basically built everything just to this. And no a motherboard from an Apple device is basically the chip, memory, a hard drive, because they basically mold the hard drive directly to the motherboard, and that's it. And wiring for the plug. But it's basically absolutely nothing. That's
Designed for manufacturer. Exactly. They're looking exactly what functions they need. What do they accelerate? And the energy efficiency that they have is fantastic. The battery life of their product is incredible.
And from an industrial point of view, the difference between an iMac, a MacBook Retina, a MacBook Air, and an iPad Pro is the aluminum box. That's it.
Maybe a bit of performance, but you're right. In general, it's the same base.
Yeah. So it's very important from an industrial point of view to understand that. So basically, a lot of companies are pushing to the ARM on the server side. Why ARM on the server side is interesting if you compare to x86?
Well, a couple of reasons. Again, one, because you have a lot of different people designing on ARM, so it opens up a lot of possibilities in terms of the software development. But two is energy efficiency, and there's no magic. There's still physics behind x86 and ARM. I could design anything I want in x86. I could design very simple solutions or very complex. Same with ARM. The challenge we have with x86 today is that it's got legacy. And with each generation, it has to be backward compatible to the generation before. So this creates a kind of a baggage, an overhead. So if I look at the performance of an ARM core versus an x86 core, for the same performance, I'm about 30% smaller in size for the ARM core because I don't have this legacy I have to support, because it's a newer ISA per server. So I get energy efficiency by using the ARM architecture that I don't have with x86 today.
If we can design a little bit the energy efficiency for the people listening this, is basically the Apple laptop on Intel was about maybe 2 hours battery life, something like that. With the M1, it's about 8 to 10 hours. We can say for the server is the same magnitude order or something like that.
Well, so it can be, but that's not just because of ARM and x86. It's because Apple had a lot more freedom of design with ARM. They built their own processor. So they put in the elements that they really cared about, right? So they're designing a kind of a boutique server for a boutique processor, let's say, not a boutique server. So they don't have that freedom on x86 today. That's the big difference. So per se, I wouldn't say that... it depends on how you design your processor. What we have is a lot of freedom of design with ARM, and we don't have a license for x86. Does that make sense?
Yes, it's perfect.
So it gives us the ability to design what we want to design.
And can we say that the kind of boutique CPU designed by Apple is the same kind of reasons why Graviton or Google are working on this kind of stuff? Because they want to design exactly the CPU they want to use, because they benchmark the CPU and say, we basically don't use that, and we pay for it, and it's absolutely nonsense.
Exactly. There's two parts of it. One is that they want to design the processor exactly for what they want. And if you look at Amazon, what do they care about? The thing they care about most is recommendation engines, right? That's really the function that they do best. They're trying to figure out, when people come to my site, what am I recommending to them? How am I auctioning off ads to them, right? Or making sure that they see the things I want them to see so that I can get the biggest part of their wallet share. If I look at what Google cares about, it's search, right? That's the number one thing they care about. If I look at Microsoft, they care about being able to put Microsoft products on their infrastructure. So all of these guys are building these processors to run their own internal infrastructure, and then they're making them available for cloud services as well. It's both. So they very much care about being able to target that processor for their workloads, for their infrastructure.
Can we say it's a kind of industrial optimization there of energy consumption on model usage and stuff? So.
Absolutely.
And what how does SiPearl sit on this? Because basically, you will be able to sold some CPU to many peoples to be sure that they will use 100% of the capacity of the CPUs or 80% of the capacity of the CPUs to make them more money and energy efficient on what they do, isn't it?
Yes, that's it. It's our target. Now, we have a broader customer base than, say, AWS is focusing on AWS workloads. Microsoft is focusing on Microsoft. We're going to multiple customers, but we do the same thing. We look at what do you care about in terms of a processor? What are the elements that you're looking for? Most of them are looking for energy efficiency. The performance to a certain level, but overall it's performance per watt per dollar. So how do we drive our processor performance for this? In HPC, it's a little different than cloud. HPC is performance first. Energy matters. It matters a lot. So we look at the different markets and we figure out how do we address HPC for performance and performance per watt, and how do we address cloud, which is really more driven for operational efficiency. And so we take these different inputs from the different customers and design to these. And yes, doing this with ARM gives us a lot of flexibility in terms of our product line.
And what is the market you target there? Military, cloud providers, big HPC maybe? Explaining maybe to the people what kind of HPC it can be.
So high performance computing, there's a lot of different verticals there. We got our seed funding from Euro HPC joint undertaking, and they actually build and buy machines for Europe, mostly around national centers, and they create consortiums around these national centers. So these guys run tons of different workloads. Scientists from many companies will come and want to run. There's probably a Pareto list of 300 workloads for each of these centers. So we have to be flexible enough to run all of these workloads and perform well. That's the HPC side. And again, it's about performance. For customers in the data center space, yes, there's military space applications, governmental applications, cloud providers for sure in Europe.
Like us?
Yes, exactly, like Clever Cloud. So we're looking at all of these markets. And in general, we're trying to find the best fit in terms of data center and cloud applications, where you're looking for probably cores that are less big, where in HPC, you're looking for very much the performance per core. So it's a bit of a mix in terms of the balance we're trying to strike for our processors.
And if we say so, one of the good point is when the first RIA 1 will be given to test to the guys, basically if the market grows, as you are fabless, you just like to order a little bit more from TSMC, so you can scale the production like quite quickly, because the production as TSMC is so big that even if you like decouple, you make 10 times your order, but for TSMC it's like nothing.
Exactly. Yeah. So again, this is one of the being.
So right now, what I'm trying to explain to the people is you're sitting is a large potential amount of gold.
Yes.
Very easy to unlock if everything goes well in the next few months.
Yes. And this is, so being a server processor company in Europe, we're alone here in terms of doing this. There are many in the Bay Area. There are some in China as well. But that gives us, it's challenging sometimes. It's been challenging to raise money in Europe. You're an entrepreneur, you understand that the view of risk for investing in high tech isn't understood as well here as maybe in the US. But the value we have is we're alone. So people see that we have access to a market and a sovereign market here in Europe. So partnering with TSMC, it's very important for us today. We don't have manufacturing of the nodes we need here in Europe, but TSMC is an important partner. We work with VCAs, value chain aggregators, to support us in TSMC. We have important partnerships there. These guys all will help us to ramp to production. And they see the value in us, even though we're a relatively small company, because we're unique in Europe. So we have access to markets and Europe that they would like to help us with.
That's very important and impressive. So how can we describe the new moves in the ARM market? So maybe we can explain that. Before, what we have explained with Philippe is at the beginning, ARM was a British company.
Yes.
And now it's no more British anymore. Maybe we can explain a little bit of the history there.
Sure.
So what is a company would try but unsuccessfully buy ARM, maybe, first, to explain this?
There were a few, but NVIDIA was probably the biggest one that was known. So ARM they're a Cambridge-based company, based in the UK, for quite a while, for a good 20 years, and then they were bought by SoftBank, which is a Japanese company.
First, NVIDIA tried to buy them.
So they were bought by SoftBank.
No, but at the beginning, NVIDIA tried to buy them, but Europe say no. I try to complete the history for the people who don't know the history.
Sure. In fact, SoftBank bought them first, and then they were going to try and buy them out of SoftBank.
Okay. So at the beginning, SoftBank buy them when?
I'm trying to remember the date. Yeah, 2014 maybe, something like
2014.
I don't remember. I have to look. So don't take this as gospel,
okay.
Right? But maybe 2015.
So a little bit more like 10 years ago.
Yeah.
Okay, SoftBank buys them. So SoftBank is a third Japanese fund, third Japanese telco, and very large hedge funds on the Japanese market.
Big investor in tech, absolutely. Yeah, a lot of investment today in AI and in different telcos, and a lot of investment in tech.
And they bought they bought ARM, and basically they let them operating like all they want.
Exactly. They were trying to help them to grow. So they were using their relationships in tech to try and help ARM actually grow. At the same time, they were leaving them free to run their own business. Exactly.
Okay. And then what happened? So many people try to buy ARM from SoftBank.
Yeah. So there was a point where there was a consortium that was trying to buy them and sort of create a new Intel. And this was headed by Renee James, who's running Ampere Computing today. She had the idea to vertically integrate on ARM the same way that Intel had. She had been president of Intel. She was number 2 in Intel when she had this idea, I think, originally. And that didn't go through. It was fairly quiet in the market, so it wasn't really publicized, but that was the idea. Then Jensen from NVIDIA kind of had the same idea, that I want to buy now ARM and do a kind of a vertical integration and have it front end my GPUs, was his idea. And so he could have CUDA on the CPUs and the GPUs.
Which is already doing it, because NVIDIA is producing a CPU also on top of ARM.
Exactly.
And basically, because you have the Grace Hopper, which is a CPU and GPU together, mixed for embedded device, we can say like that.
That's correct. So, well, I mean, it's a server processor, but he's putting the two together. So he has the acceleration, the GPU acceleration with the server front end, and then it allows him to actually have a lot of interaction between the two. So for instance, he can do power steering between the CPU and GPU.
And you are also the Grace, which is not the Grace Hopper. When we say the Grace Hopper, is because you have the Grace core, which is an ARM core, and the Hopper, which is the famous H100 you have heard about, speaking about LLM computation system.
Exactly.
But if you have the two, you have the Grace Hopper. If you have the Grace, we see that for when they have the CPU alone, it's not a very publicized market on NVIDIA.
No, I would. It's certainly not as let's say famous or popular as Grace Hopper, as the solution of the two together. But it's a market they're trying to grow on the compute side. So the idea is they create what they call a module, and it's kind of a small daughter card. We call it a daughter card. They call it a module, where you have Grace and Hopper together on the card, and then you have the memory on the card as well. They use LPDDR, low power DDR, and so what they do, instead of putting Grace and Hopper on this module, they put Grace and Grace. So it doubles the CPU compute, and there's no GPU. And the idea is then this is a server processor. It's had some success in the market. They're looking at continuing that with the next generations of processor as well. For us, as a ARM server processor vendor, again, this is helping us to grow that software ecosystem. The more people who are building ARM server processors, the more and more that software ecosystem grows, which means that ARM has a larger place in the market and people are then happy to buy ARM. And this is what we've seen over time.
So for you, it's a good news.
It's good news. Growing the ecosystem is good news for all boats rise with the tide.
Which is awesome. So basically, right now there is a new Renee James tried to buy it.
They did a vertically integrated by ARM. Yep.
And and it didn't work, and she created Ampere after.
She created Ampere after.
What is Ampere? Maybe we can explain a little bit to the people.
So Ampere Computing is a company that was developing server processors based on ARM technology, targeting the cloud and hyperscaler market. They was recently announced that ARM is buying
Kind of SiPearl, but on the Silicon Valley.
in the Silicon Valley, exactly.
Just to explain, what was the amount of money raised by Ampere Computing?
3 billion.
3 billion.
Yeah.
Can you remember the amount of money raised by SiPearl?
A little over 100 million.
A little over 100 million.
Yeah, 140, 150. I don't know the exact number today, but
So they have like
less than
30 times more money than you.
Yeah.
And you're still producing some CPUs. That's nice.
Exactly. I agree.
So Ampere, so she didn't succeed to vertically integrated ARM, so she created something else.
Exactly.
Very clever girl, Renee.
She's got a lot of experience in the semiconductor arena.
Each time I read something she wrote, I was like, okay, she basically understands everything about the way it will work. So
She was president at Intel. She has to understand the semiconductor business, absolutely.
I think that the most regency, I think one of the biggest mistakes of Intel is to not name her president, because I think that Intel will be thriving with Renee James at the top of the company.
Dissecting Intel in the second half in the 2010s, and I mean, there's probably a lot of business schools that are looking at that today. Yeah,
because really she totally understands the market from a technical, industrial, and marketing point of view. It's very brilliant. So she creates Ampere Computing, and basically SoftBank still have ARM, but they decide to put a little bit more money on ARM, and the breaking news is SoftBank is buying Ampere.
Ampere Computing, exactly, for 6.5 billion, I think. So she did okay.
Yeah, she did
A
okay.
$3 billion investment and got bought for 6.5. Yeah. Yeah.
I think investors have their return.
I think they're happy.
And so basically, SoftBank is making the vertical integration everyone is speaking about in ARM, and everyone was trying to do. And do you think it will change a lot the ARM market? Because SoftBank will not close the ARM market, isn't it?
I think their goal, in my opinion, will be to keep it open. So ARM has spent a lot of time getting into hyperscalers. And it's a big focus for them. And that's a door opener. These guys are market makers. So if you have that technology in the hyperscalers, that's good for ARM. That grows ARM. I mean, today we talk about ARM quite a bit, but I think the market share they have is something like 5% of the total server market. It's projected to grow, and it's growing fast, but it's still not that much. So it's a lot of greenfield right now for ARM server processors.
So the ARM processor is like 99% of the smartphone market.
Absolutely.
Something between 15 and 20% of the laptop market, and 5% of the server market.
And if we look at the IoT markets, it's dominating, and exactly, yeah. So there's a huge market.
The dominating, but on the IoT, you have like smaller stuff like RISC-V.
RISC-V is coming now. Exactly.
A lot of very, very small architecture you never heard about, like the ST. What is the name of the ST architecture?
I haven't looked at it. I haven't looked at the IoT market.
The F41 or something like that. You have also the SP and stuff, but it's to be fair with the listener, like it's absolutely not the same market. Basically, if you speak about IoT and embedded system with the people of the CPU, they're just looking at you with like blurry eyes, and so they're just like, what does this guy are talking about? Because it's not their job. But what is really the price of the real one?
Well, so it's not something I don't know if we published that, but it's on the order of, let's say, 6,000 euros.
So it's a 6,000 euro price. Just to remember, when I was building the maker, the central processor unit of the market is the ST microelectronic ones. It's the F411. It's a chip we have at like 45 cents.
Exactly.
So it's not the market at all. It's absolutely not the same market.
It's not our market for sure.
And
Yeah.
that people need to understand, like, what does ST, Bosch, and all these companies are wonderful, and I will try to have an interview once with ST Microelectronics because it's very interesting, but it's not absolutely not the same market. So
Agreed.
so right now, what you see that this market will be thriving and very interesting for you.
Yes. Yeah, it's growing fast. So again, we see that the ARM server processor market it's projected to be, I can't remember the official numbers now, something like 30% of the total server market by 2030. It's growing quickly, right? And so we're at a point right now, we're at an inflection point in the market. And with AI now, we're seeing more and more growth and more players coming in, and they can be designing on different ICs. Could be RISC-V, could be ARM, but the CPU part. So accelerators might be any ISA. The CPU part, again, you have to be able to support that software ecosystem. So it's either going to be x86, and again, there's two players, PowerPC, which is one player who's sort of moving out of a lot of markets today, IBM, or ARM. So ARM is well positioned in the ARM in the server CPU market to grow exponentially, and that's what's predicted.
And we speak a lot about RISC-V also. Maybe you can describe what is RISC-V and how you see the market about RISC-V?
Sure. So RISC-V is a let's say an open architecture. It's not open source, but it's an open architecture. Anybody can take the license and design what they want.
Yes, because it's an open hardware group, which is a sub-foundation of the Eclipse Foundation.
Exactly. So it was created in Berkeley. The architecture, the ISA itself was created in Berkeley. It's really interesting for universities to use because there's no licensing fee. So if I'm a student looking at how to design microprocessors, I could take RISC-V and try a bunch of things from IoT processors up to maybe, multi-core, 10 cores, 12 cores, or even bigger if I want. Now, it's a relatively new ISA. It's much newer than ARM, for instance. So I don't have the same class of high-end cores that I have today for x86 or for ARM, but that's coming. So what we see is in universities, it's used quite a lot. Well, if you want to grow an ecosystem, a great way is to get it in the schools, get young people playing with it so that they're familiar with it. It's coming into the lower end, the IoT markets today. And slowly, we expect it to grow up into all markets. Today, it's, for server CPUs, it's challenging because that software ecosystem I talked about takes at least maybe 10 years to grow. But
Or more.
But on the accelerator side, you might have more luck because you're orchestrated by the CPU. So you don't have to touch all the same elements of that software stack.
And on the future of what does SiPearl right now, you have all the here one will be out on the shelf like somewhere this year, something like that.
And in production next year.
And what is the future of product you can see on SiPearl? What is the goal of SiPearl for the next few years?
So our first generation, we focused on HPC for a couple of reasons. One was we were seed funded by the Euro HPC joint undertaking. So there's an interest in Europe in growing the ecosystem around HPC, and SiPearl is part of that. Beyond that, we want to move into other server markets. So certainly cloud computing. We talked about whether it's on-prem, so enterprise, or whether it's public cloud. We want to move into these markets. So our second generation will focus more on what we call data center. And we will have some HPC offerings there as well. But the other reason we started in HPC is getting into data center, you have to have people have to see your product, understand it, and think, yes, I trust that these guys have a product that works. HPC, people are willing to, as we say, kick tires, try new technology, port code. So it's a good place to start because it's kind of the Formula One of server processors. It's the highest end. And if I can build a Formula One car, everybody believes I can build a Fiat.
And the relation you build with someone which is building HPC is way stronger. So basically you will have like people, it will be easy to have the people like 2 or 3 big contracts on your setup.
Exactly.
For the year. And they can help you debug, they can help you make the software.
They want to know what's under the hood. Exactly.
And basically if you give them like 10% acceleration or 5% energy efficiency, they will have their payback of working with you very quickly. So that's a very good market for you to start.
And even beyond this, in Europe, users want to use European technology as well. So they see a value in local supply. This is important too.
It's something that is very important to understand, that many people doesn't understand the way that the infrastructure work. And at CleverCloud, we are well known for rewriting a lot of stuff and recompiling all the stuff. And that's why for us it's very easy to integrate ARM stuff, and that's what we are doing right now with you. And we have like few research projects on this. But it's something you need to understand is the energy bill we have is so high than a 10% reduction of the, and we're not talking about 10% reduction of the project we're working on together. We are speaking about the reduction of the energy about like 70 to 80%. So it's very huge. But even a 10% reduction of the energy bill is something that can pay the salary of like 3 or 4 people working on this. So that's something you need to understand. There is, why are we so focused on the low level? Because just a few % of economy there, it's a huge leverage on the bidding point there, and that can draw the difference between European cloud provider and American cloud provider. Because if Amazon is able to shrink the invoice they have on the Graviton, if we don't do that, they have like so much more margin than they can pay a lot of R&D we cannot. So that's why it's so important, I think, to display that.
I agree, and that's one of the things we want to bring to data center is, so you have the hyperscalers who have the scale to do things themselves, and we want to work with the providers who are not quite that big to give them opportunity to build more custom solutions, maybe integrating accelerators with CPU compute in a way that it allows them to compete with the hyperscalers in terms of solutions. And having that access to ARM processors, for instance, is part of that. So we see an opportunity also in Europe where people maybe don't have the same scale and budgets to build a custom CPU in-house. We can help them to do something semi-custom, let's say.
And maybe there is something we can discuss to in front of the public. We have a research project with company which is but we have also Visora, which is working on accelerator for LLM. We have Calre, which making the DPU, so the data transfer. Exactly. Everything is on the hardware. We have a software assembly production, which is 2CRSI. So we have like the CPU, which is the SiPearl, the accelerator, which is the Visora, the DPU, which is the data transfer, which is Calre. We embed everything in the server, which is the 2CRSI, and the software stack is made by Vates, and ZDML, which is an accelerator for LLM, but they basically rewrite all the software stack around there. And once I will go to an interview with Steve, but the point is creating an entry-level discussion with Steve will be quite complicated, but we will do it. And you have the CleverCloud orchestrating everything with a few other partners. And with that, we basically have the stack of an hyperscaler. And that's something maybe people need to understand. If we combine all the human people working on this, it's less than 1,000 people. But if you look at Google, for example, there are like 120,000 people working there. So it's something you need to understand. It's a huge, complex industrial stack with all the chain of value. And what we try to do in Europe right now is combine them together. And that's something
we're talking about, building ecosystems, exactly, and making sure we have know-how for the different elements here in Europe so that we can work together on solutions. Yeah, and sort of bring many together to make one.
Yeah. And that's something very important to understand, I think, from there. I hope everything we discussed there have helped many of the listeners to understand the semiconductor market and what we do there. And I hope it brings a lot of understanding on this market, about the production, about how it's made, why SiPearl is doing. And what I try to explain is how SiPearl is doing an industrial capacity that we don't have in Europe before, and how it's very well thinking in the market. So thanks a lot for everyone to listen this, and thanks a lot, Craig, to be with us.
That's fun.
And we will continue a little bit with Philip a bit later.
Perfect.
Thank you for listening Opening Voices. We will continue our interview with the SiPearl team in a few days, so follow us and subscribe not to miss our next episode.